NASA's latest revelations about the interstellar comet 3I/ATLAS have sent shockwaves through the astronomical community, challenging our understanding of cosmic wanderers and sparking debates that blend cutting-edge science with the thrill of the unknown. Imagine a colossal icy behemoth born under a distant star billions of years ago, hurtling through our solar system at breakneck speeds, defying expectations at every turn. This isn't science fiction. It's the real story unfolding right now in 2025. As we dive deeper into the data from Hubble, the James Webb Space Telescope, JWST, and other observatories, the anomalies pile up, leaving experts puzzled and viewers like you on the edge of their seats. Stick with me through this journey, because by the end, you'll see why 3I/ATLAS isn't just another comet. It's a messenger from the stars that could rewrite the rules of the universe. And trust me, the twists keep coming. Let's start at the beginning, the discovery that kicked off this cosmic drama. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, a NASA-funded telescope network designed to spot potential Earth threats, flagged a faint, fast-moving object streaking toward the sun. Designated as C/2025N1, ATLAS, and later confirmed as 3I/Atlas, the 3I standing for the third interstellar object ever detected. This visitor from beyond our solar system was no ordinary find. Unlike comets born in our own Oort cloud, 3I/ATLAS originated from another star system, making it a rare interstellar traveler. Picture this. While most comets loop around the sun in predictable orbits, this one is on a hyperbolic path, meaning it's just passing through, never to return. Its speed, a blistering 210,000 kilometers per hour, the fastest ever recorded for such an object. That's like crossing the distance from Earth to the Moon in under 2 hours. As astronomers scrambled to train their telescopes on it, the initial images revealed something extraordinary. An active comet with a glowing coma, a hazy envelope of gas and dust, signaling that ices were sublimating as it warmed under the sun's rays. But as we'll uncover, this was only the tip of the iceberg. What makes 3I/ATLAS so captivating is its sheer size, which has astronomers rethinking the scale of interstellar visitors. Early estimates from Hubble placed the nucleus diameter between 0.32 and 5.6 kilometers, but newer observations from the Vera C. Rubin Observatory pushed that to about 7 miles, or 11.2 kilometers wide. Some analyses even suggest it could be as large as 15 to 20 kilometers, or in one intriguing flux-based calculation, up to 46 kilometers across. To put that in perspective, that's roughly the size of Manhattan, dwarfing the previous interstellar objects. The first one Oumuamua discovered in 2017 was a cigar-shaped rock estimated at just 100 to 200 meters long, with no visible activity. The second, 2I/Borisov in 2019, was about a kilometer across and showed comet-like behavior, but nothing on this scale. 3I/ATLAS's massive core means it's carrying a treasure trove of ancient material, potentially forged in a star system billions of years older than our sun. Why does size matter? A larger nucleus implies more mass, more ices, and potentially more dramatic activity as it nears the sun. But it also raises questions. How did something this big get ejected from its home system and survive the interstellar void for eons? As we explore further, you'll see how this giant's journey is packed with surprises that keep pulling us in. Now let's talk trajectory, the path that's got everyone buzzing. 3I/ATLAS is barreling through our solar system on a near straight line, thanks to its extreme orbital eccentricity, which makes its trajectory look more like a slingshot than a loop. It will reach perihelion, its closest point to the sun, on October 30th, 2025, at about 1.4 astronomical units, or roughly 210 million kilometers, just outside Earth's orbit. From there it swings outward, but not before making notable passes by inner planets. Recent updates show it's currently headed toward Mars, with a close approach that could allow Martian rovers and orbiters to catch a glimpse. It won't get closer than 1.8 astronomical units to Earth, posing no threat, but its route also brings it near Jupiter later on. This sequence, skimming the Sun, brushing past Mars, and grazing Jupiter's influence, creates a gravitational ballet that's mesmerizing to model. Using NASA's Horizon system and advanced ephemerides, scientists have mapped every twist, velocities peaking at 58 kilometers per second, angles aligning with the ecliptic plane at a mere 5 degrees retrograde inclination. But here's the hook. Simulations suggest the odds of such a large object threading this path are slim, echoing the improbability seen in earlier models. While not as razor-close as some early speculations, no 0.19 astronomical unit flyby of Mars, the alignment still defies easy chance, prompting questions about cosmic selection or hidden dynamics. As 3I/ATLAS races on, each planetary encounter could alter its course slightly via gravitational assists, much like how we propel spacecraft. Hang tight, because this path sets the stage for the real enigmas. Diving into the anomalies, one of the most intriguing is the comet's sunward features, which have sparked intense scrutiny. High-resolution images from Hubble and JWST reveal an anomalous anti-tail, a plume of material appearing to stream toward the Sun, contrary to the usual tail pushed away by solar radiation pressure. Normally, comets develop tails pointing anti-sunward due to sunlight evaporating ices and solar wind sweeping particles back. But 3I/ATLAS shows a sunward glow that's 10 times longer than it is wide, a stretch feature that's baffled observers. The Atlas team attributes this to a shift from dust scattering off a reddened surface to fluorescence from ionized gases, but it's still classified as anomalous. This wrong direction behavior echoes puzzles from Oumuamua's acceleration, where invisible forces seemed at play. For 3I/ATLAS, it adds to the unsettle. Is this a trick of optics or evidence of unique physics? As the comet approaches perihelion, expect more data to clarify or deepen the mystery. You won't want to miss how this evolves. Adding layers to the puzzle are the spectroscopic scans, which peel back the comet's chemical secrets. Using instruments like JWST's NIR-SPEC and SPHEREx, astronomers have detected an unusual abundance of carbon dioxide, CO2, making up 95% of the dust coma, with only 5% water and traces of carbon monoxide, carbonyl sulfide, and water ice. Strikingly, there's nickel present without the expected iron, a composition unlike typical solar system objects. In standard comets, you'd see strong signals of cyanogen CN and diatomic carbon C2 as volatiles evaporate, lighting up spectra like a chemical fingerprint. But early observations of 3I/ATLAS showed a nearly blank spectrum where these should blaze, with CO2 dominating instead. Only later did faint traces emerge, delayed and weak. This mismatch suggests a hardened crust from interstellar radiation, shielding inner ices or exotic materials from a foreign star-forming disk. Think of it as a campfire roaring without smoke. The activity is visible, but the usual signs are absent. This chemical oddity not only challenges comet models but hints at diverse cosmic chemistry. As more spectra roll in, could this reveal building blocks of alien worlds? The implications are huge, and we're just scratching the surface. The color changes are another showstopper, enhancing the visual drama of this interstellar spectacle. As 3I/ATLAS nears the Sun, it's shifting from a reddish hue to a vibrant green, a transformation captured in real time by telescopes like Gemini South. This anomalous evolution is linked to the activation of CO2 and other gases, causing the coma to glow as sunlight excites molecules. It's like watching a cosmic chameleon adapt, growing a tail in coma that's both a scientific milestone and a source of wonder. Polarization studies add to the intrigue. 3I/ATLAS exhibits extreme negative polarization at negative 2.77%, with a low inversion angle of 6.41 degrees, setting it apart from prior interstellar objects. This optical anomaly suggests unusual dust properties or surface scattering, further marking it as different. Viewers, imagine the footage. A Manhattan-sized giant turning emerald against the black void. It's visuals like these that make astronomy addictive. Stay tuned for what this color shift means for its fate. Probability and statistics bring the wow factor to a fever pitch. Running Monte Carlo simulations, dynamicists have calculated the rarity of 3I/ATLAS's path. With its size and velocity, the chance of it aligning for close planetary passes, Sun at 1.4 astronomical units, Mars encounter, Jupiter skim, is extraordinarily low, though exact figures vary. Some estimates put similar events at less than 0.005% in vast trials, akin to hitting specific cities on a spinning globe blindfolded. This isn't just luck. It challenges passive solar system models. With only 3 interstellar objects known, having one this massive and on this route is a statistical outlier. It prompts, are there more out there, undetected? Or is something guiding these visitors? While chance plays a role, the numbers demand deeper probes, fueling ongoing debates. Enter AI, the game changer in unraveling 3I/ATLAS's secrets. Quantum-inspired AI systems have analyzed vast data sets, flagging periodicities in brightness curves and subtle accelerations. These tools sift through photometric data across telescopes, detecting rhythms like a hidden heartbeat amid dust chaos. One simulation even raised horrifying implications, though largely speculative. Harvard's Avi Loeb suggests AI could spot complex patterns hinting at non-natural origins, though NASA emphasizes natural explanations. The detected acceleration, about 10 to the minus 7 meters per second squared, exceeds pure gravity, possibly from outgassing or radiation pressure on a thin, reflective surface. But with delayed gas signatures, models struggle. AI's parallel processing is like hearing a single note in an orchestra storm. Revolutionary for astronomy. Standard explanations? They're being tested rigorously. Outgassing jets could explain deviations, with exotic ices like CO2 vaporizing unevenly. Shape irregularities, perhaps elongated or lumpy, might cause tumbling and sporadic activity. Artifacts from data stacking are ruled out via crosschecks, yet none fully fit the sunward features, chemical delays, or polarization. This gap invites exotic ideas, a thin sheet acting as a natural solar sail, or fragments from a shattered world. Loeb floats alien tech, even mini-probes, but NASA debunks, calling it a comet with anomalous traits shared by others. The debate rages, but responsibly, science thrives on questions. Age estimates elevate 3I/A TLAS to relic status. Independent analyses peg it at 3 to 11 billion years old, potentially the oldest comet observed. Originating from a star cluster, perhaps 8 billion years old, its trajectory traces back to ancient stellar nurseries. This makes it a time capsule, preserving pristine materials from the universe's youth. Observational campaigns are in full swing. JWST's Webb observations captured precise spectra, while SPHEREX mapped the coma. Ground-based like X-shooter probe gas environments, as perihelion nears, brightness may peak, offering naked-eye views or rover snapshots. Implications? 3I/ATLAS challenges assumptions about interstellar objects, hinting at abundant cosmic wanderers. It enriches exoplanet studies, revealing foreign chemistries. And while alien hype grabs headlines, the real thrill is discovery. In summary, 3I/ATLAS, a giant, ancient, anomalous comet, forces us to question deep space secrets. With its size, path, chemistry, and AI-flagged oddities, it's a story unfolding live. Thanks for watching to the end. Subscribe for updates as this cosmic saga continues. The universe keeps surprising. What's next?